Okay, so this is our next lesson in our very short trigonometry unit, our intro to trigonometry unit. So just a little reminder as we go through this. So remember that trigonometry, when I say trigonometry, it's the study of triangles. And when I say triangle, I mean a three-sided shape. Oops. Right, so that could be like this, it could be like this, it could be like this. These are all triangles, right? Like, ooh, really long triangles. The point is 3 sides, 3 angles. And specifically with what we're focusing on here in grade 10, we're looking at right triangle trigonometry. And that's because right angles have some really special relationships. So that's why we kind of start there. And when I say right triangle, I'm talking about triangle where one of those 3 angles is 90 degrees. So when we're talking about trig ratios, ratio being talking about relationships, right? So ratios are relationships that are set in stone. So if one side is a length of 1, the other will always be a length of 2, right? And so that's a ratio. We talked about Pythagoras, where one side is the square of the 2 other sides squared. And right now we're talking about sine, cosine, and tangent. So for these 3 ratios, and for Pythagoras, it's really important that we know which side and angle we're talking about. So when it comes to these triangles, there's 3 sides. There's the hypotenuse, there's the adjacent side, and the opposite side. And it's really important that we can identify where those sides are based on the angle that we're looking at. So in every single triangle, the hypotenuse is going to be the same. The hypotenuse is the longest side, and it's always going to be, you'll notice there's this box here, right? That's the 90-degree angle, the right angle. The hypotenuse is always across from that. So for every triangle, the hypotenuse will be the same. Our opposite and adjacent depend on what angle you're looking at. So if I'm looking at this angle down here, and I'm going to use a new symbol today, this is what we call theta. Theta is the symbol, kind of like a variable. And we use it to show an unknown angle. So it always is talking about an angle. So if this is my theta, it's important that I know that that is the angle I'm looking for. As opposed to in this triangle, my theta being up here, right? So this is 2 different angles I'm looking for. So if this is my unknown angle, the opposite is going to be across from my unknown angle. So that's my opposite. It's opposite the angle. My adjacent is going to be attached to that unknown angle. Okay, so whereas for this triangle, if my theta, I'm just going to recolor this so it's a different color, is up here, we still have opposite and adjacent, but they're going to be different because this time, down here is opposite to that angle, and this side is adjacent or attached to that angle. So those sides change depending on what we're talking about, but the hypotenuse always stays the same. So it's important to know what angle we're talking about and which sides we're talking about. So when we're using these, the ratios are important. So we remember it using kind of the acronym SOHCAHTOA. So sine, right? So the S is sine, theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. And tan theta is opposite over adjacent. So these can all be used on the same triangle, but we use the one that helps us depending on what we're looking for. So remember that there are 3 variables here. There's theta, which is an angle. There's opposite, which is the side opposite. There's A, which is the side adjacent to theta. And then there's h, which is your hypotenuse. So to use one of these ratios, pieces of information. And depending on which two we know, we can find any missing thing. So a reminder from your calculator time, and I'm going to use my Desmos calculator on here. This is the one that I found kind of the most useful. So if I want to find a ratio in decimal form, this is where I'm going to be using my sine, cosine, tangent button. So this it would be like finding a missing side. So I would go sine 35. Remember, this is where it's going to be different depending on your calculator. 0.57. Cosine 25. I would go cos. Cos 25. And some of them are backwards, so you need to check your calculator. And tan 45. That says 15. And that's 21. If we're looking for theta, the missing angle, we're going to have to use that inverse function, which remember requires that second floor button on a lot of calculators. So on this calculator, there's a function button. On a lot of other calculators, it requires an up button or like a second floor button. So this one as well, I would need to use that second floor button. So I'm going to go sine -1 point, oh, we gotta go back to numbers, 0.435. So this angle is going to be 26 degrees. So theta is 26 degrees. Okay, so we're going to go function cos -1, because that's going to find me an angle. We're going to go 0.135, 82 degrees. And tan, same thing, we got to go second floor because we're looking for an angle, 0.555, 29 degrees. Okay, so those, we're going to be using those calculator functions today when we're looking at our angles. So, what we're going to do today is actually use those to find those missing sides. So first step always to me is to label that O, A, and H. Label your opposite, your adjacent, and your hypotenuse, because then you're going to use that to figure out your SOHCAHTOA. So from my 90 degrees, this is going to be my H. This is my theta, right? My angle. My other two sides are based on that angle. So I'm going to go across is going to be my opposite, and attached is going to be my adjacent. So now I got to figure out whether I'm going to use sine, cosine, or tangent. So I always look at, well, what do I know and what do I not know, right? Because we want to pick the ratio that has the information that I'm looking at in my question. So from my question, I know theta, and I know, where is it? Opposite. I need H. So what that means is I need to find a ratio that has that information in O and an H. So I look here. Sine is O and H. So that's the ratio I'm going to use. So we're going to go, this is my theta. This is my H. And this was my O, right? So I go sine. And then my theta was 62. Opposite here, 15. And my hypotenuse is x. So that x is what I'm looking for. So remember, to solve a problem, we need to get x by itself. Okay? So that's our goal here. So first thing, and that's going to be a little bit easier to work with here. So we're going to go, oh, this calculator's backwards. So we're going to go 62 sine, because this time I'm using a weird calculator that goes backwards. So 62 sine. So know your calculator. So this is going to be 0.8829, so it's going to be 883. So I need to get this x by itself. So anytime that x is on the bottom of a fraction, we need to get it out of the bottom of a fraction. And to get an x out from the bottom of a fraction, we multiply both sides by that x, because that's going to cancel my x over here. And so what I'll be left with is 0.883x equals 15. So we're not done yet because x still isn't by itself. So remember, what's happening here is a multiplication. So to get rid of a multiplication, we do the opposite of a multiplication, which is a division. So we're going to divide by 0.883 on both sides. We'll be left with x equals 15 divided by 0.883 equals 16.98. So that's going to round up to 17. So here my hypotenuse is 17 millimeters. And that unit is important because it's given to me in the question. If there's no unit in the question, you don't need to include it in your answer. So let's try that again here. So remember, my first step is going to be to identify my sides. So here's my h. And then my theta opposite is going to be opposite my theta. And adjacent is going to be attached to my theta. So what do I know here? I know theta and I know h, right? They have numbers attached to those variables. What I want to find here is a. So once again, we're looking at a and h. So we go to my SOHCAHTOA, right? Which ratio contains a and h? OH? Nope. Here's my AH. So that means cosine is the ratio I'm going to be using here. So cos theta is adjacent over hypotenuse. And then we're going to fill in those numbers. So cos, which is the one I'm using, my theta here is 35 degrees. My adjacent and my hypotenuse is 15. So once again, to solve this, we need to get x by itself. And if I have this cos of 0.819, what 8191, so it's going to be 819 x over 15. So if we have a fraction, we want to get rid of that fraction. We do that by multiplying by the denominator, which will cancel that fraction. So we'll just be left with the numerator. So I'm going to have 15 times 0.819 is 12.285. And on this side, I'm just left with x. So there we go. That's it. So here, my x is 12.285 millimeters. And we might be asked to round that. Here, we were not asked to round it, so we can decide. We can leave it, or you could say that this is 12, or you could say that this is 12.3. Depends on what rounding the answer is looking for, right? This would be to the nearest whole number. This would be to the nearest one decimal place. So look at your question, make sure you know what the answer is looking for. Okay, so first step, we got to label our side. So h is always going to be across from the right angle. Then I find my theta. Opposite is across, adjacent is attached. So what do I know? I know theta, and I know opposite. What do I want? I want A. So I'm looking for the trig ratio, and once again we're going back to that SOHCAHTOA. So I'm looking for one that has O and A. O and H? No. A and H? No. TOA is the one I'm using now. So that means tan opposite over adjacent. So tan, and my theta here is 40. Opposite is 7. Adjacent is x. We need to solve for x. First step, if I can, let's get rid of that tan. So we're going to go tan 40 or 40 tan, depending on your calculator. 0.8390, which will stay at 9. Now we want to get rid of my x. So we multiply both sides by x. And so this is just the same thing we're doing every time, right? Let's get rid of that denominator so that we're not dealing with fraction anymore. So we're going to have 0.839x is 7. And then we got to get x by itself. Because this is a multiplication, we divide to get x by itself. X equals 7 divided by 0.839. 8.34. And we don't have a unit here, so I can't put a unit on it. Once again, you're going to check your question to see if it's asking. Mine doesn't ask for a certain length of answer, so I can kind of decide, and I like the 8.34. I might round it to 8 because the other one's a single number. All right, so first step, hypotenuse. Now, this one doesn't have a box in it, but we can kind of assume that that's our right angle, right? The one that looks the most like 90 degrees. We need to find our angle because we need that to know where the opposite and the adjacent sides are. So what do I know? I know theta, and I know h. What do I want? O. So what am I looking for here? O and h. So we go SOHCAHTOA. We're looking for the one that has O and h. So sine is what we're going to be using here. So you'll notice there's kind of a trend here. Once you get this, once you can kind of figure out where the sides are, a lot of the calculations are going to be very similar, right? The tricky part is setting it up right. As soon as you've set it up, it's just plugging numbers until you get the answer. So sine, and our angle here is 35. Opposite is x. Hypotenuse is 9. So we're going to try and get rid of that sine. So we're going to go 35 sine or sine 35, depending on your calculator. 0.573. Now notice this is 5735. So I'm going to round that up to 0.574. But this is where if you know how to use your calculator, you're going to get a more accurate answer. Because what I'm actually going to do here is I'm going to leave that sine 35 in my calculator when I'm calculating with it. And I'll show you what I mean by that here. So instead of clearing my calculator in between, because that's a number that I'm going to use here, I can leave it. And when I press multiply, it'll actually carry that number on. And instead of having to use the rounded one, I can use the whole number. Because remember, the more decimal places you have, the more accurate your answer is. But a lot of times we have to round just for ease of writing. So here I'm actually going to try and carry that sine 35 into my next number. And the more you do that, the more accurate your answers will be. But sometimes rounding can be easier for people. So I'm going to go sine 35 times 9. So I got 5.162. So I'm going to go 5.16. And this is in millimeters. So we're going to find a missing angle here. Now, please note that our steps here are the exact same. The only difference is going to be around what is missing in your questions. So this time we're going to do the same thing. Hypotenuse. The difference here is, notice that our theta is not actually an angle. Our theta is an x. It doesn't actually affect our setup at all, right? Our hypotenuse is the same. Your opposite is across from the unknown, and your A is attached. That's still an angle that you're looking for. So that's still the one that we're going to use. So what do we know this time? I know O and I know H. I need theta. So this process, this setting up process, is the same, right? I know O and H. Those are two sides, so we're going to use sine. So then we're just filling those numbers in. But this time, I can't fill a number in for theta, so I put the variable in there. And sometimes it'll be a letter, sometimes it'll be a theta, but they're the same idea, right? They're just a variable for a missing number. So O is 4, H is 7. Now this looks actually a lot like problems you've seen before, right? We know that sine x, we could take that fraction and turn it into a decimal. So remember that when you see a fraction like that, it means 4 divided by 7. So when I go into my calculator, I'm going to go 4 divided by 7. So I get 0.571. Now this is like what I told you before. You could clear your calculator and input the number 0.571. But your calculator will carry that number if you want it to, right? And for a lot of the more scientific calculators, you can actually pull on the number answer. But if you just leave it in there and do your next step, it'll hold on to it. So here, remember, to find a missing angle, we do that sine -1. So in my calculator, and this one, because it's got that in there, I'm just going to go second floor sine -1. And notice that if we expand that calculator so you can see it bigger, it's actually kept that whole decimal and put it into the sign. So once again, a more accurate answer. Realistically, we're not going to need that many decimals anyways, and so the degree of 35 is what we would get from the abbreviated answer anyways, but it's nice to carry that number through just to get the most accurate. So what that means here is theta is 35 degrees. So let's try that here. So once again, hypotenuse, theta is the angle, opposite is across, adjacent is attached. What do I know here? I know H and I know A. What do I want? I want theta. So I'm looking for that O, A, and H. So, nope. Yes. So cosine is going to be the one that we're using here. So we're just plugging numbers in. This time, I don't know what theta is, so it's going to stay. Once again, you can write A, you can write theta. The variable doesn't matter. What matters here is that that's what's missing. 7/9. So for those of you that kind of are following the same steps, you can do that again. I want to show you something a little bit different as well, particularly for those of you that have fancy calculators, that are actually using scientific calculators, because this is actually a very simple thing to put into your calculator. And you don't have to do that division. The calculator will do it for you. So what we can do, because we know that we're looking for this angle, right? Which means we're going to need to use that inverse cos. And you can actually plug it in all at once. So you can plug it in as a 7/9. You can also plug it in as a 7 divided by 9, depending on your calculator. We can do that all in one step. So if we look at my scientific calculator here, what we're going to do is we're going second floor cos. And we're going to go second floor cos of 7 divided by 9. So it'll actually do that all in one step instead of having to copy down every step. So this is going to be 39 degrees. So let's try that again. Hypotenuse. Remember, theta is what we need to know where your opposite and your adjacent are going to go. So what do I know? O and A. What do I want? Theta. So if O and A is what I'm looking for, so it doesn't work. CA doesn't work, but TOA does. So that's what I'm looking for. So I'm going to be using tan here. So we're going to plug those numbers in. Tan theta, 5/8. And so I'm going to show you another fancy calculator trick, and this is where knowing your calculator is going to be really helpful because some of those scientific calculators make your calculations so much easier. So with some of them, you're actually going to, be able to just plug it all in at once. Just like the other one, but it looks a little bit fancier even. So we're going to go 10, -1, 5/8. So if we look at my Desmos, so this is a really good one to use if you are using an internet calculator. This Desmos scientific calculator does everything we need it to do. Okay, so we're going to go second floor tan. And then you actually have this fraction button. So that allows you to just put the straight up fraction in and not even have to worry about having to divide. And a lot of scientific calculators have that little fraction button, this A/B. So take a look at your calculator and see if it does, because it makes your life a whole lot easier. So my missing angle there is 32 degrees. So hypotenuse, theta, opposite, adjacent. What do I know? O and H. What do I want? Theta. So look at that. We don't even have to go through all of them because that matches my sine. O/H. (9/10). And so when we've got that fancy calculator, we're just going to go sine -1 of 9/10. Because that sine -1 is how we find that missing angle. So I'm going to go sine -1, fraction, 9/10. 64. Now remember that if you don't have that button, you can go, right, we'll get the same answer if we go 9 divided by 10. So we take that 0.9. And we can actually use this answer button. So what the answer button does is it pulls up the last answer you have on your calculator. So I can go sine -1 of my answer, and it'll pull up that last answer. We get the same answer. Okay, so that's getting used to and using your calculator is just going to make your life easier. But you end up at the same answers whether you do it the long way or whether you do it with fancy calculator shortcuts. All right, so that is your Trig assignment for today.